Example 3 says identifying characteristics from functions. You are going to copy down this entire example. So if you want to pause the video now to go ahead and copy it down, do so you can actually listen to me explaining the example. So it says find the vertex, the equation of the axis of symmetry, and the y-intercept of each function. So example A says y equals 2x squared plus 4x minus 3. Now earlier when we wrote down our key concepts in our Cornell notes, we wrote down the formula for the equation of axis of symmetry. That formula is x equals negative b over 2a. So many of you are probably wondering, what is a, what is b? Well, we also wrote down, when we wrote down those key concepts, the standard form for the quadratic equations, which is ax squared plus bx plus c. So here, if you label the actual numbers in front of the variables, you would have a x squared, so a would be 2, plus bx, so here b would be 4, plus c. So here c would be negative 3. So when we plug those values of a and b into our formula, remember a is 2 and b is 4. When we plug those values in and solve, we get x equals negative 1. That is the equation for the axis of symmetry, x equals negative 1. I didn't mean to press that one. I meant to highlight. Okay, so now we got one part done, the equation for the axis of symmetry. So now to find the vertex, use the value you found for the axis of symmetry as the x coordinate of the vertex. Find the y coordinate, use the original equation. So the original equation they gave us is y equals 2x squared plus 4x minus 3. This value here, x equals negative 1, that is what we're going to plug into the equation to find the actual y value. Remember, our vertex is the axis of symmetry, and it's also the minimum or maximum value. It is those two key concepts together. That is what gives us our vertex. So by using the axis of symmetry and plugging this value of x equals negative 1 into our equation, we get y equals negative 5. So if x is negative 1 and y is negative 5, our vertex happens at negative 1 comma negative 5. For the last part, which is our y-intercept always occurs at 0 comma c. This is important to write down. We already wrote that in our key concepts of y is c. In our original equation, c is negative 3. So the y-intercept is negative 3. So just by looking at the equation, not even by graphing it, just by looking at the equation, we can find the vertex, the axis of symmetry, and the y-intercept. So let's take a look at the second example, example B. Example B, we're going to be finding the same exact things, the vertex, the y-intercept, and the axis of symmetry. So the first thing we found was the axis of symmetry just by using A and B. So if we look at our equation, A here, even though there's not a number written there, we know there's a 1. So A is equal to negative 1. So we plugged in negative 1 for A, and here B is equal to 6, so we plugged in 6 for B. When we solve this equation out, remember you can type that in the calculator exactly how it looks. You get x equals 3. So our equation for our axis of symmetry is x equals 3. Next it says we're going to use that x equals 3 and plug it back in to find what the y value is. So when we plug that 3 back into our equation and solve it out, remember you can type that exactly into your calculator. You get y equals 13. So now that we have our x and y value, we know that our vertex is at 3 comma 13. Our y-intercept comes straight from our equation. Our y-intercept is this c value. It's the constant value at the end of the equation. So our y-intercept is 4. Now, for the guided practice, I want you to answer these two questions, 3A and 3B, in your spiral. You should have copied these examples down on your Cornell notes, but the guided practice, make sure you complete in your spiral. Watch the next video for the next example.